All right, here we get some heavy, not heavy vocabulary, but a lot of vocabulary. It's not that heavy because it's words you have already learned. For instance, we have variable. The definition of a variable is a symbol, usually a letter that represents one or more numbers. Typically, you see X, Y, and Z are probably the most you're going to see in math, but we use them all. A, B, M. The only letter that you typically stay away from is I, and I will explain that in the next couple chapters. An algebraic expression, really quick, expressions do not have equal signs. That is why they are considered an expression. This entire lesson, we're working on expressions. An algebraic expression contains one or more variables. So like x plus y, algebraic expression. Or just 4x is an algebraic expression, or just x by itself. Evaluate, it means to plug in numbers for the variables and then follow the order of operations. Typically, an evaluation will leave you with a number as the result. Notice I don't have anything for term. Term is essentially what is separated by plus and minus signs. For instance, let me try to bring this up. Sorry, I thought I already had this tab open. So if we looked at one of these problems, for instance, let me find some with variables here. This 15, a term, like I said, is separated by plus and minus signs. So because this is division, this actually is one whole term. And then this would be a term, this would be a term, and this would be a term. So essentially there are 1, 2, 3, 4 terms here. And if I wanted to actually simplify further, these are like terms because they are the exact same variable, because there are two terms with the exact same variable. So we can combine those like terms, and really, so this really simplifies down to 3 terms. This and then these two group because they are the same, and then this one. Another example, and I can just make this up, would be like 2 plus 4. They're like terms. They're both constants, so they're like terms. 2x minus 7x, or sorry, 2x minus 7z plus 4y. That would be 3 terms because there are 3 separate parts separated by the plus and minus sign. Let me give you an example of that, what I just said. 4x plus 5y minus 7z. I think I changed the order, but that's an example. So this has, this has 3 terms because of how it's separated. Remember, it's separated by a plus and minus sign a term is. So there's 1 term, 2 terms, 3 terms there. Coefficient, well, in the problem above, it would be 4, 5, and -7. A coefficient is the number in front of the variable. And we already established this, but a like term are terms. So like this 4x, 5y, and -7z, they are terms that have the exact same variable or variables. So like 4x squared and 7x squared are like terms because they have the exact same variables with raised to the exact same powers. So like 4x and 7x squared are not like terms because one was raised to an x and the other is raised to a squared. So it has to be the same variable raised to the same powers. All of that will pretty much be on your vocab quiz this week. And now we go back to evaluating expressions that we've already worked on last lesson and that you should be extremely familiar with from geometry and Algebra 1. So evaluate, again, follow our order of operations, GEMDAS. So z is 2, so we can plug in 2 for all of our z's. Why am I starting with z first? Because that's inside my grouping symbol. So I'm looking here. So I have 2 plus 2 squared. All right, now I notice I'm not adding, I'm not doing anything yet. I just substituted. Now it's exponents, grouping symbols, which we looked inside. Now within the grouping symbols, we have to do the exponents first. So 2 squared is 4, so now we have 2 plus 4. Those grouping symbols are still there. So we have y minus the group 2 plus 4. Well, 2 plus 4 is 6. So we have y minus 6, and y is 10. 10 minus 6 is 4. Okay, here you might say, oh, that's a lot of grouping symbols. Yep, there's definitely some grouping symbols there. So in this case, our grouping symbols, we have m. So we do the innermost first. Okay, now typically in our books, you'll probably see it drawn like this. You'll have a bracket around the outside parentheses and then parentheses inside. Bracket, again, grouping symbols. So we do the innermost parentheses first here. So we're going to do m plus q first. Well, m is 4 and q is 3, so we have 7. So we have 9 minus 7. Well, 9 minus 7 is 2. So we have p minus 2, and p is 5. 5 minus 2 is 3. So that simplifies, it evaluates, simplifies to 3. And then this last one, 2x cubed, use x equals 2. Now I threw this in there because a lot of people just think that this 2x is the base, and we do 2 times 2, which is 4, and raise that to the third power, and that is incorrect. This is 2 times x to the third. In the order of operations, you have to do exponents first. And there's no grouping symbols that groups anything together. So x to the third, we don't know, but 2 to the third, because we substitute 2 in for x, is 8. So we do 2 times 8, which is 16. All right, 2 times 8 is 16. And then let's look here, simplify these expressions. Now notice there's no evaluating. There's no numbers that we can plug in. So it's just a matter of simplifying. Now there's nothing we can evaluate and plug in. Simplify means combine like terms. So looking at this, I see a variable of x, and I see another variable of x. So these are my like terms. So what I just circled, my like terms, I add. So I'm going to do negative 2x plus 6x, which is 4x, and I have 4x plus 11. Now, can I do anything else? Can I do 4 plus 11? No, because they are not like terms, so you're done. Okay? Still follow your order of operations here. Grouping symbols, so look inside. When I look inside my grouping symbols, there's nothing I can combine because there's no like terms, and there's no value I'm supposed to plug in for n. So that is merely just 9 minus 10n. Now I still drew the grouping symbols there because of this subtraction sign. What we can do here is we can actually subtract. So we can do negative 2n minus 9 minus 10n. Now when we subtract, again, we have to subtract like terms. 9, if you notice, doesn't have a like term, so I'm just going to put a 0 there. So we're essentially doing 0 minus 9, which is negative 9, and we're going to do negative 2n minus a negative 10n. Negative 2 minus negative 10 is the same thing as negative 2 plus 10, so we actually have a positive 8n there. You might say, well, hold on, you can use the distributive property there and distribute the 9. And yes, you can. However, I found that no matter how many times I teach that, a lot of people still forget it. But as soon as I teach this, go back to subtraction of setting it up vertical, there's a lot less people that make that error of distributing the negative. And they can get the right answer more often this way. So that's why I like to teach it this way. And lastly, these are the problems we will be working on in class tomorrow.